Good morning, everybody. My name is RJ Sunderman, and I am a product engineer on the GeoEvent extension for server development team. Over here to my left is Ken Gorton, a solution engineer joining us out of our Washington, D.C. regional office.
Good morning.
Today we're going to be taking a look at real-time analytics, a portion of what you can do inside the GeoEvent extension for server. If for some reason you guys do need to leave early for any reason, that is perfectly fine. Please, though, do take a minute to provide us some feedback on the Esri Events app. Let us know, was the session presenting what you expected, or was there something that we can do to change, that something you needed or wanted to hear wasn't being presented? The GeoEvent extension was released initially at 10.2 with 3 key capabilities, and at 10.4 we have added 2 capabilities to that list. We're aiming to be able to provide a configurable way to easily ingest data into the ArcGIS Enterprise. We're looking to perform real-time analytics on that data as the data is ingested, and that is the focus of this session today, looking in detail at some of the processors that are available out of the box. New at 10.4 is a big data store that we are archiving the data records and the event records that are received. And then we also provide a way that the accumulation of big data can be visualized effectively on a map. And then our 5th point, being able to, once we have identified events of particular interest, notify those who need to know in a way that is meaningful to them, sending an SMS text message, an email message, in some way making sure that they don't have to be a slave to a web map waiting for a red light to turn green or vice versa, but they can receive a notification that something of interest has happened. We're going to be taking a look in this session at these 8 different processors highlighted on the screen, and I'm going to give an overview of each processor conceptually in slides, and after I do 3 or 4 of the different processors, I'll be cutting over to Ken to do a demonstration where he can show you how he has used those processors as part of a solution and then is displaying the data up on a web map or the operations dashboard. So let's take a quick look then at what the operations dashboard is and how we can use it once we have GeoEvent ingesting data to then display that data up on, well, an operations dashboard.
All right, thanks, RJ. Now, all the examples that we'll be showing you this morning have to do with a law enforcement use case, but virtually all of the tools that we'll be talking about can apply to countless other use cases. So in this case, we'll be looking at some paroled felons in the California penal system. And each of them is issued a ankle bracelet GPS that sends its location at regular intervals, and parole officers then can watch, observe the movements of their charges, and conceptually determine that, whether or not they're doing what they're supposed to do, being where they're supposed to be, and so forth. Now, the problem with this system is, while it sounds great, it generally generates a flood of information. You can see here in these news clippings, these are the news clipping itself is made up, but it's copied from actual news articles. You can see here in the center column that the agents are drowning in this sea of information, and they can't make decisions because important information is getting lost in this flood. In the rightmost column, you see that agents are so busy reviewing GPS logs and GPS tracks that only about 12% of their time is actually spent out in the fields, knocking on doors and talking to people. And perhaps the most disturbing part down the lower article snippet is the director of corrections for the state of Colorado was actually killed in his home by someone who had cut off his ankle bracelet GPS about a week before the crime, and no alarms were if the alarms were sounded, nobody heard it, nobody listened, nobody took action, potentially could have corrected it. So GeoEvents then is a tool that has the potential to allow us to sort through all this flood of information and be able to determine, allow the system to help the parole officer decide, when is something of real importance. So this dashboard is really the end product of that entire chain of information management. Of course, we see a map here, and there are parolees represented as points moving around the map. You see a list of them, of these felons listed here on the left-hand side, and the parole officer can click on any one of these and see details about the person. But now, what the system does is, as the parolees, the GPS reports their location, the system then can determine if certain things have happened. You notice that with some of these individuals, their parole restrictions prohibit them from meeting with certain people or maybe entering certain areas. So we can geofence those areas, and if the GPS determines that they've entered an area where they don't belong, then that can alert the parole officer. Similarly, if they stop reporting their location, if they disable their device, or if they cut it off, or some other way stop the flow of signals, we can determine that we haven't heard from this individual's device in a certain amount of time, and then the parole officer can receive an alert. Or if they stop moving, if they're hanging around someplace a little bit too long, maybe someplace they really shouldn't. That kind of information is important to a parole officer. And so in the two lists that you see here on the lower right-hand corner, those notifications are being sent out. And while they appear here as a list item, they could also go out as a text message or an email to the parole officer. I would like to point out also that each of these incidents that are listed there include the street address. Now, the GPS reports its longitude and latitude, but one of the processors that we'll be looking at today is a reverse geocoder. So it'll take the longitude and latitude and turn it into a more understandable street address, so the parole officer knows just where he or she might need to go to take care of this. And so this really is, like I mentioned, the end product. We'll take a look at each of the steps in the workflow of information here in the GeoEvent services. Now, there's one thing I would like to point out, hopefully in order to resolve a little bit of confusion that a lot of people have. We're looking at the operations dashboard here. And of course, in the background, GeoEvent's the GeoEvent extension is running. I want to make it clear that there is a certain set of steps that the data have to go through from GeoEvents to the operations dashboard. So the GeoEvent extension is generating a lot of information and sending it to a feature service. That feature service then is added as being consumed by a web map, a standard web map like any other in ArcGIS Online, and then this operations dashboard is consuming the web map. So I don't want to paint a picture that makes people think that GeoEvents will push information directly to the operations dashboard. That's not how the architecture works. Just want to make that clear. But let me turn it back over to RJ, and we'll take a look at some of the processors that are put in place to drive this, and then we'll take a little closer look. Are you up?
There we go. Thanks, Ken. So what is GeoEvent extension, and where do these processors go? We create inside the extension what we refer to as a GeoEvent service. And illustrated here on the screen is an input with several processors, a filter, and then a few different types of outputs. One of the first processors is a field calculator, and it's going to do something fairly simple, converting either feet or meters into miles, and then you see the top event flow sending that data out to a stream service. So that could be the extent of your real-time processing, to take event data in, make a small calculation, and then send it back out for something downstream inside your enterprise to consume. Following the middle of the event paths, after we do that first calculation, we could enrich the event data with parolee data. If you think about it, a fixed sensor is probably not reporting to you a wealth of information. It's going to have probably a location, a date, time, and some sort of sensor value. If we want to take a track ID or a serial number, or in some way we know what that sensor is, and then go off to an external table, we can pull in additional information. And Ken will be showing that to you in demonstrations, how we can enrich event records with pictures of the parolee, hair color, eye color, all kinds of attribute information. The filter there is showing that we can discard events once we have determined that a given condition is or has not been met. In this case, if they're not a known gang member, we'll just discard the event. And then down on the bottom, we have a ability to create a dynamic buffer around the events that we receive, another field calculator that's tagging the event with some information, and then maybe a field mapper. So let's take a look at what some of these different processors are. A field calculator, like I mentioned, is going to take a expression, evaluate the expression in order to write a result either into an existing field or a new field. And in this case, we're just going to do a simple mathematical calculation, taking feet and converting it over to meters and putting the value out to the same field distance in the output event record. But a field calculator is much more powerful than just doing a feet to meters conversion. You can invoke different methods out of the Java string library, some of which accept regular expressions. This can make a field calculator very, very powerful when you want to do string manipulations, pattern recognition, and pattern replacement. If you'd like to take a look at something I was able to do using a chain of field calculators, please come down to the island and I can show you how I was ingesting what was just a set of YX coordinate pairs and actually using it to produce an Esri geometry so that I could display the polyline up on a web map. The field enricher, like I said, is responsible for going out to some sort of external table, doing a join based on an attribute, usually your track ID, and pulling in additional information. So in this case, we're going to assume that the suspect ID is our track ID. It's maybe the serial number attached to that ankle bracelet. And we're going to go out and enrich in order to pull in some contact information, or more appropriately, who this particular person is not allowed to come in contact with, and maybe an area that they're not allowed to enter. The buffer creator is one of our spatial processors. We have about a half dozen of those available out of the box. And what we're doing here is we're bringing in a point event stream, but we want to be able to do some spatial analysis, such as, does this point location intersect with another known felon? Or does it intersect with a known geofence? By taking the buffer processor and putting a geometry around that point, we can choose to either replace the event's geometry or, just like the field calculator, add the geometry to a new field. And where this is really powerful is now we're not talking about, say, U.S. counties or U.S. states or operational areas or something that is relatively static in nature. We're taking highly dynamic data, generating buffers around it on the fly as that data is received, and then we're able to push that geometry back out in order to do real-time analysis. The field mapper is probably one of the simpler processors and one of the first that you'll be working with if you're new to GeoEvent. The role of a field mapper is to take an input schema, an event definition, and map it over to a different schema or event definition. Often when you're bringing data into GeoEvent, you have very little influence over what that data looks like, and you need to write it out to a feature service. Yes, you could probably publish the feature service so that it looked exactly like the data that you were receiving, but even more often you're going to be receiving in, say, a JSON record, and it has a hierarchical structure, maybe with lists and sub-elements and other things that aren't supported by a feature class's event definition or schema. So you'll need to take data out of the records that you received and transfer them over into the data record that you want to write. In this illustration, I'm using the field mapper as kind of a simplifier. I'm taking just 4 of the records out, the suspect ID and date, and then the geometry and category, and mapping them over to an event record that I want to use either for later processing within the event service or something I want to stream out again for consumption later in my enterprise. So having taken a look at just 3 or 4 of those processors, let's hand it over to Ken and we can do a demonstration using the field calculator, the enricher, the buffer creator, and the field mapper.
Did it switch? All right, thanks, RJ. So first of all, I want to show you the service that we'll be looking at, and then I'll start a simulator and we'll look at the results of this service. And now, as RJ mentioned, the input here, one of the first things it does, the input is represented by the green rectangle. And so as messages come in, it will recalculate one of the fields. Now, before I get into that here, let me show you what one of these records looks like. That'll put it in a little bit better context. So this spreadsheet shows just one of the records for the parolees that I'll be pushing through the simulator, and we'll be able to look at what GeoEvents does to it. There are a few fields, of course, that are of key importance in this message, in this data record. The first, of course, is the date time field. Now, the simulator will take this date time. It doesn't matter what is in the record. It'll replace it with the current date time of the system where the simulator is running, so that it'll appear in GeoEvents as a current date time rather than something that happened back in 2014. Another key field here is the second column, the suspect ID. You'll notice that each of these records is identified by a unique value. Since there are 13 felons in this file, the track ID for each one of them is the unique ID, and that represents the GPS device rather than the person to whom it's assigned. And then one of the processes, of course, is we'll geo-enrich this record with additional information about the person who's wearing that device. It also provides us with the means to update individual records as new information comes in. Of course, we have a longitude and latitude value that'll be key for the location. And we have a distance in feet here in column I in the spreadsheet. This is the first processor in the first service that we'll be looking at here. We'll convert those feet into miles because that'll be easier for the parole officers to interpret how far the individual in question might have traveled since the last time they reported. All right, so in this service, as I mentioned, the first thing we do here is recalculate the distance field from feet to miles. It's a simple mathematical calculation by dividing feet by 5,280. You notice that we'll put it into the same field, so we're not adding a field, although that is a possibility. We could add a new field, and if I do that, I can give the new field a name, determine what kind of field it is, double, text, date, whatever it might be, and then you'll notice that it would generate a new GeoEvent definition because the schema will have changed. The schema of this message will have changed. But I don't need to do this. I'm going to just put it right back into the same field, so we won't. We don't need to generate a new GeoEvent definition. Now from there, we go ahead and send that information directly to a pair of outputs, one of which is a feature service. We're writing it out to a feature service, and that's simply so that we can see it in the operations dashboard. Feature service can appear in a web map, and the web map can be used in operations dashboard. But for purposes of our demos today, we're also pushing this information to a stream service. And the stream service we'll look at in the web map directly in the ArcGIS Online Map Viewer. Now in the second, this middle line of logic, this is where we enrich the information. So remember that coming off the field calculator, it's still just pretty much the raw GPS ankle bracelet information, pretty spare information. But we want to enrich this with information for the parolee himself. So let me edit this and we'll have a look. So the message coming in needs to be joined. Essentially, it's a join. So we'll take the suspect ID in the the track ID in the incoming message, which remember that contains the unique value of the unique ID for the GPS receiver, and we need to find information elsewhere. In this case, it's from a feature service that to which we can join that information to. So I specified a connection to an ArcGIS server, a folder, and a service connection. I've specified the individual layer. This particular layer is just a table. It's a flat table, so it's not a feature class itself with geometry. It's just a table that contains the additional personal information for each one of these convicts. And I'll specify that I'm going to add new fields. So this is actually going to change the schema of the message that propagates through GeoEvents. And I'll add each one of these fields, the first and middle and last name, gender, date of birth, etc. You notice there's also an image. And that's really, it's a URL to an online image for each of the felons. And then what gets generated then is a new GeoEvent definition, the new schema for the new message that has the original ankle bracelet data fields as well as the personal information fields for the convict. And again, we push that information out to a stream service as well as to a feature service. Now, in the bottom row of logic, we take the information that's coming off the field calculator, again, the spare GPS, ankle bracelet GPS information, and instead of working on the point location of where the felon is, we're actually going to buffer. We're going to buffer his location. And as RJ explained, this will allow us to do certain operations to compare whether two individuals have come into close proximity by entering one another's personal space. So with the buffer creator, we simply take the incoming point geometry and we buffer it. Well, I'll say that I'm going to replace the geometry rather than add an additional geometry field to the GeoEvent definition. So I'll replace that point geometry with a new polygon geometry, buffering it by 25 meters. And because buffering it needs to take place in a projected environment, we'll specify the particular well-known ID for the output projection. And that's what we'll send. Again, we'll send this out to a stream service. But before we do that, we'll have to add a couple of additional bits of information. One, again, is a field calculator. And in this case, we'll be adding a new field. And because we want to use these polygon buffers as geofences, I'll show you in just a moment, we'll actually synchronize the output stream. But one of the requirements of setting up a geofence is a category field. So what category do these fall into in order to be able to distinguish it from other geofences that we might have within our system. So I'll add a field called category, and I'll calculate it with the value in quotes here, ankle bracelet GPS. So that will be the category for all of the personal buffers, the personal geofences that populate that geofence. And then finally, we as RJ mentioned, the field mapper simply allows us to map an existing GeoEvent definition to a new GeoEvent definition that makes sure that it conforms in field name and type to the schema of the output that we want to send this message to. So with that, we'll take a look at how this it works in a web map. Notice we'll see the point of each of these individuals, but we'll also see the enriched attribute information and the buffer for where they are located. So I'll start the simulator here, and it's sending points at one event every 300 milliseconds, so just about 3 events per second. And you can see that as the simulator sends their information, these points they'll move around the map. They'll make small movements. You can see. And if we click on any one of these, there we go. You notice that not only the location there, but the additional personal information is added in. And I'll zoom way in here so you can see this particular one. You notice that the buffer is there, and as his position changes, that buffer changes immediately with him. So this is that dynamic geofence that we'll be using in later steps in our processing. Now, the last thing here, the buffers that are coming off the stream are all being populated in our geofences. as a synchronized set of geofences from, with the source from that output stream from the GeoEvent service that I just showed you. And you notice that each one of these individuals has a personal buffer with a category of ankle bracelet GPS and the name of the unique value of the GPS bracelet. So with that, I'm going to turn it over to RJ, and we'll take a look at some of these other buffers, or some of these other processors.
So when the product was first released at 10.2, we had a concept of geofences that was primarily point-in polygon. And that's what we usually think about as a geofence, as an area. So here illustrated on the screen, we have a couple of highlighted events. We supported the notion of inside and outside, and we also provided some stateful tracking that allowed you to say whether an event had entered an area or had just left an area, so that you weren't being constantly told inside, still inside, still inside, still inside. At 10.3, we released some additional spatial processors, and that allowed us to expand the scope of what we consider a geofence. So illustrated here on the screen, we have the different Java geometry API functions or operations that you can do to prepare an expression for spatial evaluation. We can now check to see whether an event's geometry intersects a geofence or crosses a geofence. We can see whether an event's geometry is within a geofence. And to kind of bring this point to bear, we can have a geofence that is not necessarily only an area, but here we have the event data that's coming in as a polygon, and our geofence is actually a point, a critical facility. And once we detect that that polygon's buffer intersects the critical facility, we use GeoEvent to prepare a notification. We put a link into an email address or an email that we send off to an address, and that allows a recipient then, taking that email, to click on that link and immediately dive into a map and get situational awareness about something that's happening. This is actually a workflow that's being used heavily by our colleagues out in Esri, Australia in the insurance industry. They want to know that when critical weather events are coming in, what the intersection is with the assets that they're insuring so that they have real-time knowledge of what their exposure is to the upcoming event. A little bit more traditional case looking at geofences. Here we have some high-value construction equipment, and we've zoned off some different areas of the construction site so that we can track and say when a given vehicle has exited an area, is entering another area. And you see over here on the right, one of the vehicles has left the construction zone entirely and is tooling up this road, probably causing no end of damage. We need to classify that as a separate type of alert and go to figure out, it's like, get him on the radio and tell him he needs to get back inside the construction zone. What is he doing outside that area? This slide, I'd like to talk to you a little bit about the scope of your spatial comparison. So if we're looking at building an expression for spatial evaluation, we want to read this from left to right, starting with selecting an event definition. This is really just a helper in order to narrow down which fields you want to work with, because the GeoEvent definition itself is not actually part of the expression. But we select a field, in this case geometry, and then we select an operator that is relevant for that geometry. In this case, I'm choosing intersects. The scope is what you pick by selecting any or all. So I want this evaluation to apply to either any of the geofences that I'm considering, or it needs to satisfy the condition for all of the geofences. And in this case, I have the geofence set selected as dot star, dot star. That's a regular expression, meaning all of the geofences will be in the set, but I'm going to construct the expression so that it needs to simply satisfy the condition for any of those geofences. Taking a look at this in graphics, the highlighted points on the left intersect any of the three geofences. On the right, if I wanted to intersect all of the geofences, of course the geofences would have to overlap because there's only one point that simultaneously intersects all three geofences. Where this kind of gets confusing is when you look at the opposite of intersects for something like disjoint. On that right-hand illustration, there are only 2 points that are disjoint all geofences, obviously the 2 that are outside the overlapping areas. However, a lot of those points are disjoint any, because they're inside one, but disjoint from the other 2. So when you're going to construct the operator, pay attention to any versus all and what you're doing with the geometry so that you get the results out of your filter or your processor that you're expecting. Where do geofences come from? Typically, new users are going to be loading geofences in from a feature service. So again, a feature service could have point, line, or polygon geometry, and we're using that geometry to model some area of interest or something about an area that we're interested in, such as a critical facility that is a point location. So we import those from a feature service, and you can set up a synchronization rule so that periodically it will go out to the feature service and look for updates. And in that way, your geofences start to become dynamic. But if you really want your geofences to be dynamic, rather than using a feature service, you want to use a stream service. Stream services are a type of output supported by the GeoEvent extension, and in these demonstrations, what we're doing is placing a dynamic buffer around a point, again, to push that buffer, that polygon, out a stream service, and then have GeoEvent subscribe to its own stream service to bring that data back in as geofences. And now the geofences truly are dynamic, because rather than waiting for 30 seconds or 5 minutes or whatever your polling interval is to go out and discover edits that have been made to a feature service, you're receiving that data in real time as it comes in the stream service. So let's take a look then at geofencing, geotagging, and that reverse geocoder, which I will take a look at as an overview of reverse geocoder after the demonstration.
All right, so the first service that I showed you was all about where these guys are. We buffered them, we mapped their location, we added attributes. The remaining 3 services that I'll show you in the next few demos are more about analyzing their activity and whether or not they're behaving themselves and going where they're supposed to. So in this first one, we'll take a look at some geofencing. Part of the personal information that we enriched each of those points with in the first step of these demos was their parole restrictions. This individual can't enter a certain known gangland or can't enter a boundary near a certain school. And so if the point indicates that they've entered that area, the parole officer needs to know that information. Likewise, even if they don't have a restriction, but we begin to see a pattern where somebody who doesn't have the restriction is very frequently entering a known gangland, it could be that maybe there's a new pattern developing that the parole officer would be interested in knowing too. So even if it's not technically a parole violation, just the pattern of activity is important to know. So in order to determine this kind of information, this service starts out by generating an incident. And the incident essentially is determined by whether the geometry, if you notice the opening condition here, whether the geometry of where that felon is located is inside any of the ankle bracelet GPS geofences. So notice the category there, the ankle bracelet GPS dash geofences. These are static geofences. These are not the dynamic buffers that we talked about, which we'll see here in more detail in a little bit. But these are static, defined geofences, known ganglands, areas around a certain school, the U.S.-Mexico border, things like that. So if the individual has entered any of these geofences, we're going to generate an incident. Now, remember, this is not yet saying this is a parole violation. We're just comparing locations at this point. But now, one of the bits of information that will be part of this incident, though, is the track ID of the particular felon. And that will become important in one of the following processors. Now, after we've determined an incident that such and such an individual has entered one of our geofences, we still don't know which one, we use a geotagger processor to identify which of those geofences he entered. So the geotagger simply adds an additional field to our incident message that was generated in the previous step, and it said these are the geofences in which this point is located at this particular moment in time. So at this point, we might see that he's entered the known gangland or a certain school boundary, and that will generate a new GeoEvent definition. And so this becomes one more definition in our library of GeoEvent definitions. So now we know who is in question and what geofence they've entered. With the next one, we will enrich their information with their actual parole violations. Right? So we take the personal information and we use a field enricher just like we did in the previous step, and we'll add whether and what their parole violations are. Their no contact and their no entry parole restrictions. So now, with the conclusion of that step, we know who's doing it, where they went, what geofence they entered, and what their parole restrictions are. We still haven't made the comparison of whether they are restricted from entering that particular area. You follow me? We just know that they may or may not have restrictions. So it's the field calculator here gives us is an additional step, but it's these filters up here that will determine whether or not any violation has occurred. So I'll get to that in a second. The field calculator that we have here is simply nothing more than a nice way to add a message for the parole officer. So-and-so entered such and such a place. So that's all really that's doing. And when the alert goes out, if one should go out, that's useful information. But it's these filters here where we'll actually determine, based on all the information that we've accumulated so far, whether or not any violation has occurred. And so we can simply say, if the value of that no entry parole restriction field is equal to the name of the geofence that this person has entered. In other words, he's restricted from entering this place, and yet the name of the place he entered is that place. Obviously, there's something going on there, and so we're going to call this a potential parole violation. We'll add a field calculator that actually adds that information. We'll say in the name field will be listed as parole violation, and we'll send that to our output. The opposite of that, you notice it's very similar here, is that it's that same expression where no entry is equal to the geofence, but we negate it with a logical not. Right, so essentially those filters are very similar, but we're simply saying that it will get through one of those filters, but not both. And that's one of the nature of one of the characteristics of a filter is that some information by definition simply won't get through. By contrast, our processors are considered to be non-destructive. A processor might not operate on a message going through it, but the message will still go through. So our filters are actually restricting some of that information going out. Finally, we'll talk about the reverse geocoder here. The parole officer might be able to use longitude and latitude, but a street address is in most cases far more helpful. So we'll take the longitude, latitude of this location of this incident where the person entered a geofence. We'll send it to the ArcGIS Online reverse World Geocode Service and call the reverse geocode method to find the nearest street address within the user-defined 100 meters here. And that's the value that gets returned to that gets sent out in the stream service. All right, so let's have a look at this. I'm going to start one simulator here. Now, this particular individual, I'll zoom in here a little bit. You can see if we take a look at his profile, you know that he doesn't have any parole restrictions. Nothing says he it may not enter any particular location. And so he has the freedom to come and go as he plays from within this known gangland, the Temecula gangland. And so no alerts are being generated here at all. All right, it's a non-issue for the parole officer, unless we see a pattern where he's spending a little bit too much time there. But that goes beyond the scope of this. Now, if, on the other hand, we take a look at this other individual, and we'll have a look at his characteristics here. This individual is prohibited from entering this Temecula gangland. And so as we watch his movement around the, there we go, getting some alerts there, a little bit of latency, not sure why that, we'll figure that out. But as he's moving around the map, we're getting alerts that saying that he's potentially violated his parole restrictions. And so then the parole officer could receive notifications to that effect, and then take action, follow up with that individual, and see what's going on there. So that's a look at static geofences. In the next demo, we'll take a look at dynamic geofences. But let's turn it back over to RJ and take a look at a few of the processors.
So there are a couple of processors in the product that operate as monitors. A lot of the processors you deal with are going to take an event and, like a field calculator, add or slightly change the event that they receive. One of the processors that acts as a monitor that gives you out a completely different event record is the incident detector. With an incident detector, an event comes in and it is evaluated against an opening condition. If that opening condition is satisfied as true, a new incident gets created and then begins to be tracked over time so that you know the elapsed time for that incident. So here we have maybe 3 event records that come in. Finally, one of them satisfies my opening condition. You can see there I have an incident ID at the top, I have a status of started, and highlighting here I'm saying that I'm taking the track ID out of the event that I receive and pushing it into that incident record. It's important to note that the incident detector is not preserving the event information that it received other than the track ID. So we have a continuing set of incidents or a continuing set of events here, and you can see that our incident manager has ongoing and is tracking the cumulative time for this incident. And then eventually we get a record that satisfies the closing condition and the incident is ended or closed. We receive a couple other events. They're not satisfying the opening condition. We don't create a new incident. So there you have a series of events that came in. We have a few incident records that came out, but not one for every single event that was received. A geotagger, as Ken was demonstrating, is a form of enrichment. So when we bring geofences into the GeoEvent extension, we're placing them in a category, we're giving them a name, and of course they have a geometry. But that's all the geofence has. By design, it's very lightweight because these are being maintained in memory. You might be passing 100 events a second, you might be passing 1,000 events a second. We don't have time to go down to the database and pull the feature service every single time to figure out what that geometry ought to look like and have the rich set of attribute information that the feature service has. We load those geofences into memory. So the geotagger is taking a look at the geometry that the event has and then comparing it to some expression or evaluation that you configure inside the geotagger in order to say, yes, it is inside, or yes, it does intersect, or yes, it is disjoint. And then you can enrich the event record with the name of the geofence or geofences that satisfy that condition. The reverse geocoder we're including not only because it makes for the good story and completes what we're trying to say with the story and the parolees, but it's not one of the processors that's available out of the box. GeoEvent extension has a Java-based SDK, and Ken was able to use that SDK to prepare a fairly simple custom processor. This is going to be calling against the World Geocoding Service and then returning whichever address is closest to the point location that the processor received. So obviously you have some freedom there, some latitude as to how you want to implement the custom processor so that it satisfies the nature of real-time streaming data without being interactive, providing you a selection list, but maybe it will return different results based on the score or whatever comes back from that geocoding service. So here we receive an event record in, it has a geometry that is a point, and then we're enriching the record with a bunch of information based on the closest address. So let's take a look then with dynamic geofencing, the incident detector, the geotagger, some filtering, and the reverse geocoder.
All right, having a look at the service first. This service, of course, obviously it appears very similar to the one we looked at in the last demo. And logically it is. It's still doing geofencing, but there's a key difference here that I want to point out. So remember the last one we determined with an incident detector, which we have here, if the parolee had entered any geofence. And in this case, we're checking to see if it's inside any, you notice the category here, ankle bracelet GPS. It's a little bit distinct from the last one. This is the ankle bracelet GPS. This is the category that we enriched a field with in the very first demo, if you remember, so that we have that category value. So if he's inside any of these that represent the personal buffers of all these felons, then that's an incident. We haven't yet determined if it's any sort of a parole violation, though, remember. And again, the geotagger says, well, we know that you entered some, you're inside some personal buffer. Whose personal buffer are you in? Now, here's the key difference. Remember that every single message from every single parolee always gets buffered. So he's always in his own personal buffer. So that we need a way to differentiate whether or not he's only in his own, which is obviously not going to be a problem, from is he in somebody else's personal space as well? Is he meeting up with them? So that's where this filter comes in. The filter essentially says the track ID, that is the message coming in for the parolee, if it's not equal to the name of the geofence, then let it through this filter. That filters out everything where the person is alone inside his own personal buffer. So only the messages that get beyond that filter represent messages where the person is in actually two buffers, his own and someone else's. So that represents that a meetup is actually taking place. And so we follow the same logic then. Are they permitted to meet with this person, or are the parole restrictions such that these two persons are not supposed to meet up or associate with one another? And we follow the same set of logic then. We have a couple of filters. Is it a violation or is it not a violation? And if it's a violation, then we're going to reverse geocode it and send that out as an alert to the parole officer. So we won't go into the rest of that. We will take a look at how this works, though, and I'll zoom down to our meetup area. Let me start my simulator here. So I'll open up the first two of these, and we'll notice that for this top individual, his unique ID begins with F. So this individual is prohibited from associating with the parolee whose unique ID begins with V. This guy, no real surprise here. This is his unique ID begins with V, and he's prohibited from associating with the other guy. All right. So we're going to take a look at this interaction here by starting the simulator. And as they move around, you notice those buffers keep perfect time with them. And you know what I did? There we are. Let's make sure my service is started here. There we go. All right, so today it's not generating alerts. I was having some of this trouble in the past few days with this, but in our output, we can see must have got something amiss here, but it is. You can see that there's some change that apparently that I made here, and so I'm not getting any out values. But never fear. I'll show you how it's supposed to work with this nifty video. So here you can see the same thing going on. We'll start the simulator, and you can see that this person is prohibited from meeting with this other individual, and his parole restrictions state that he's not allowed to meet with this other guy, this guy named V, or whatever his name is there. And he has similar restrictions. He can't meet with this other guy. So when we start the simulator, then as they move together, they get together, doing whatever they're doing, whether it's nefarious or otherwise. Doesn't come to into the scenario here. But the fact is they're not supposed to meet up, and yet they are hanging around together. So in this case, the alert would be sent out. A message could be sent to the parole officer that says so-and-so met with so-and-so, and of course it gets reverse geocoded, so the parole officer has an address to log in his or her notes, but also someplace to go to deal with these guys. All right, so let me close up that. And so in the last one that we'll take a look at, we'll have a look at some determining loitering or a loss of signal from these guys. We'll let RJ tell us about those processors as well. There we go.
One of the other monitoring processors is a track gap detector. This is unique as one of the processors in the GeoEvent extension because usually we're taking data in, processing that data, and pushing the data out. Sometimes we're interested in the absence of events. Consider, for example, that you had a patrol car or a series of patrol cars and you were expecting to get a location report every minute. But you went for 3 minutes and you haven't gotten a position report from a particular patrol car. This might be something that is an alertable event. You at least need to get the officer on the radio and figure out, is his GPS down? Did he just leave a service area? Did he pass through a tunnel? Why are we not hearing from his location? So the track gap detector is going to be listening for event records that it receives and caching up the track IDs of each record. And then when an absence occurs, we get an event record out of the track gap detector that says a gap has started and is true. We get another absence, we get a true, and we continue getting these records until we get an event record that comes back in with that track ID, and now the gap is false. Connectivity has been restored, or contact has been restored with that element. And then as we get additional records, you see that we're not getting any output from the track gap detector because we're expecting or we're receiving the expected event feeds. This particular processor can be configured either to give you continuous alerts, the way I've shown here, or simply give you an on-change detection where the expected result is coming in, you get a gap goes to false, you get one event out, and that's the only event you receive until the gap is fixed and there is now no longer a gap is false. So let's take a look at what we might do with the track gap detector and the reverse geocoder if we had a parolee that was loitering down along the U.S.-Mexico border.
All right. Thanks. All right, so we'll take a look at the service first. And you notice that this service takes care of both of these cases. In the top row of logic, we have the track gap detector. In the bottom row of logic, we have the track idle detector. By and large, the flow of logic is the same. And the first one, we simply determine if we've stopped receiving signals from an ankle bracelet GPS. And the other one, we're continuing to receive signals, but the individuals seem to be not changing location. So a possible loitering event, a track idle. So we'll take a look at each one of these. The setting up, the configuring of each of these processor is by and large the same. So with the track gap detector, we want a continuous notification mode rather than just an on change or a one-time kind of alerting. In this case, for demonstration purposes, we dialed it back to a fairly tight window. So if it says the gap detection interval is 5 seconds. So every 5 seconds, the GeoEvent extension this processor will check to see if we have received a signal from this person within the last 5 seconds. And if so, then we're going to generate a track gap event. And the next processor then is, again, an incident detector where the opening, there we go, where the opening condition is simply if the gap field, the gap attribute of the event generated by the previous processor equals true. In other words, a track gap has been detected. And if so, then again, we'll calculate a nice message for the parole officers that so-and-so has failed to report in. Reverse geocode that and send it off to our stream service. The track idle processor is very similar. Again, there's a very tight threshold here for these individuals. After 5 seconds, if each person hasn't moved at least 300 feet, we're going to call it an idle event. And again, we generate an incident. If idle equals true, then we'll calculate a message for the parole officer. So-and-so may be loitering. We will reverse geocode that. And the message that can go out to the parole officer could be very straightforward then. So-and-so may be loitering near the following address. All right, so let's have a look at and see how that may be shaking out. Let me stop this. There we go. Don't want all those alerts in there before we're ready for alerts, right? There we go. So if I zoom in here to an area near the U.S.-Mexico border, we'll watch. Make sure that's started. There we go. And we'll start this. Watch as this individual moves down. You can see his location is moving. Right now, we're receiving a signal, so there's no track gap, and he seems to be moving fairly briskly, so there's no track idle event either. But you notice that as he gets down here and he starts to slow down, and maybe he's visiting somebody, but and we don't know where, we don't know what it is, but he's not really moving very far. He's not moving outside that 300-foot threshold, and so we get an alert that says, so-and-so may be loitering at the following address. Now, you notice here as the simulator comes to an end here, as the slider finishes sending all the information in the simulation file, we've now stopped receiving signals from this person's GPS, essentially. The simulator is done, the GPS has been disabled. And so after a certain amount of time, we'll also get an alert saying that so-and-so has failed to report in. And again, it gives the address and the date time that this incident started. So in each of these cases, an alert might go out to the parole officer saying that this has happened. And so the parole officer then can take action. So basically what we've seen here is a set of 4 services. They don't have to be broken out into multiple services, but you see that how it makes it easier to not only to understand from just from a demoable standpoint, but also it's easier from an administrative standpoint to be able to maintain and keep these things up to date. One of these services handles the positioning and the location of the parolees, while the other 3 handle the analysis of what's going on, the situational awareness. So this is just one example of how we can use analytics to control that and deal with that large volume of information that we might have to deal with. So I'll turn it back over to RJ for there we go, for the last few things that he wants to share.
So just to wrap up the session then, in conclusion, continuous analytics allows you to look at real-time visualization and better enable the understanding of your world. It allows you to capture what is happening as it happens, react and make smarter decisions faster, and be notified when something interesting occurs in your events. There are a series of product tutorials out available on the gallery. If you visit the link that I have here or go to our product gallery, there's a link on the right-hand side that says tutorials. These offer step-by-step illustrated exercises that will take you through some of the processors that we didn't cover in this session, as well as different workflows that you can do with the GeoEvent extension. These are free to download. The intro tutorial is about 300 pages, 6 modules, the rough equivalent of a 3-day instructor-led course, but it's yours free to download. And then there are other tutorials available, such as for the new spatial temporal big data store, or notifications in GeoEvent, or stream services, once you get past the intro and you want to look at specifics of the product. Here are some of the remaining sessions that we have at the conference today. I'm sorry I did not highlight which ones are already passed. Obviously, Tuesday was yesterday, so we're looking at Wednesday and later on this afternoon. We also have this printed off down at our booth on our island if you want to come talk to us about maybe recommended sessions for the remainder of the conference. Again, please, if you have Absolutely. If you have downloaded the Esri Events app, please take a moment and provide us some feedback. This is not the first time we've presented this particular story, and we're interested in knowing, has the story become stale? Does it still resonate? Is this a good example of what the processors are doing? Let us know so that we can either freshen or prepare a different real-time analytics for the upcoming conferences. With that, I think we have about 10 minutes if you want to ask any questions. I'll be happy to take them from the floor.
What is starting all this data and relatedly, if you wanted to review the analysis, this is for real-time trading things, right? Let's say you have new information where you have both data and user process. So how do you store it and then how do you run it again?
So the GeoEvent extension, to repeat the question, how is it persisting the data it receives? That is your choice. You receive an event record in, you pass it through optional filtering and processing, which was the focus of this tech workshop, and then you choose your output. You could choose to persist it as feature records in a feature class. You could just be streaming it out that another client is going to subscribe to that stream service and it is going to handle the persistence. You could write it out to the new spatial temporal big data store. So it's up to you how you want to persist that data. You could write it out to a file that's a comma delimited file and then bring that back in through the simulator that Ken was using in order to replay the data. Well, if there are no other questions then, please enjoy the rest of your conference, and we are down at the island if you want to come visit.
Thank you.